Here we are on the air. What do you need?
Don't you need to be on the screen?
Well, yes, I was just started. I was over there starting. Okay. Well, hello. We have 0 viewers with us today, but we are recording this live session. And I've written some topics over here on the side that I hope we'll be able to cover. I'm not going to be able to obviously cover all of these things, but we're going to talk about these things in the context of welfare. So we had some questions regarding how to calculate areas from graphs, and that's what we'll be focusing on today. So what I'm going to do is I'm going to start off with a set of cost curves behind me, and I'm just going to quickly go over how we can look at this graph and find totals from our averages, and using the graphs and areas to find totals. So let's start out.
And I'm going to sit down.
And Professor Mendez is going to have a seat, and then he's going to come at about halfway through and talk about trade topics. But he's going to help me out if I make a mistake. Or not. Okay, so let's take a look at what I have here. So what I have is average total costs, average variable costs, and marginal costs for a hypothetical firm. Let's say it could be producing anything. Let's say our hypothetical firm is producing shoes. So here's price. Let's say price per pair. Now, what if I asked, what are total fixed costs for this firm? We can find total fixed costs by looking at this graph. But before we think about total fixed costs, maybe we just want to think, well, we know that total fixed costs don't change as we vary our quantity. So we can look at our graph and say, let's choose a point. Let's choose that maybe at quantity 12 shoes. Let's find total costs. We have an average total cost curve, and we have a quantity. So we can find average total costs as average total costs times quantity. So we follow 12 up to this average total cost curve and find that the average total cost of producing 12 shoes is 9. And 9 times 12, oh dear. I have a calculator here, even though I can do it in my head. For some reason, when I'm on camera, it makes me nervous. Total costs is equal to 108. We can represent total costs as the area under this value, $9, and up to a quantity of 12. So this blue shaded area here represents the total costs of producing 12 shoes. But I didn't ask you about total costs. I asked about fixed costs. So in order to find fixed costs, we are going to subtract off our total variable costs. Our total variable cost, average variable cost times Q. So if we follow at our quantity 12 that we picked, if we follow this quantity 12 up to our average variable cost curve, we find that the average variable cost of producing 12 shoes is $6. And 6 times 12, I believe that is 78, but let's verify. Oh, 72. Good. It's 72. Now we can represent that, let's switch colors here, as the shaded area here. We're following 12 up to our average variable cost curve and over. So our total variable costs are represented by this green shaded area here. We can find the value, or we could represent it graphically. Now, I didn't ask about total variable costs. I asked about total fixed costs. Total fixed costs are the difference between total cost and total variable cost. And in this example, that's 108 minus 72. And that should be 36. Exactly right, 36. Now, we found this value, but we could also represent it graphically. So if we look at the difference between our average total cost and our average variable cost, that represents average fixed cost multiplied by the quantity. Represent it as this red shaded area here. Total costs are the sum of total variable costs and total fixed costs. You'll also remember that total fixed costs don't change with the quantity of output, hence the name, fixed cost. So if we wanted to, we could choose a different quantity, maybe 18, to find total fixed cost. At a quantity of 18, the difference between average total costs and average variable costs on my graph here, this looks to be approximately $2. So average variable cost is approximately $2. So total fixed costs would be represented by this black shaded area right here. And $2 times 18 is equal to 36. So anywhere on this graph that we can find a good point to find the difference between average total cost and average variable cost in a quantity, we can calculate total fixed cost. It's a difficult time at first calculating totals from our averages and finding areas, but once you get the hang of it, it should be fairly easy. I'm sure you can get comfortable with it if you practice. All right, we're going to do a little more work with graphs and calculating areas, but instead of finding total costs, we're going to find consumer and producer surplus. So I'm going to keep my handy grid here. And let's construct a demand curve. And let's construct a supply curve. Okay, I have a nice equilibrium here. And actually actually, before we construct the supply curve, let's just look at the demand curve. We'll start with just demand. So here is just our demand curve, and we can keep this as shoes. And let's assume this is a market demand curve, and we have lots and lots of consumers. So these are shoes maybe in thousands. Lots of shoes, lots of consumers. So let's suppose the price of shoes is $5 a pair. And if the price of shoes is $5 a pair, on our demand curve here, consumers would be willing and able to purchase 15 pairs of shoes. Now, I sometimes think about a demand curve, if we're thinking about a market demand curve, there's a lot of ways we can think about it, but maybe one useful way is thinking of it as a continuum of many consumers that have different preferences, who are ranked by those who value shoes the most to those that value shoes the least. Now let's think about these consumers up here. And these consumers, let's make this 13. These consumers up here are willing and able to pay a very, very high price for shoes. These consumers attach a high value to shoes. And so we can represent the value that they place on shoes as the distance between the demand curve and our axis here. So these consumers value shoes a lot. Now, as we move down the demand curve, maybe we find consumers who don't value shoes as much, or for whom, if we think about value, less. So we move down here, maybe if the price is, at the quantity of 12, according to our demand curve right here, this marginal consumer values shoes at $6. So we can think about the total value that consumers place on shoes as the area under the demand curve up to the price. And I said, let's suppose the price was $5. So here's the total value that consumers place on shoes. Now, consumers have to pay for the shoes, but they only have to pay $5. And they only have to pay $5 regardless of how much value they place on shoes. So let's think about how much they have to pay. They pay $5 times 15. So this is the amount we can think about. This is the surplus, or it's not surplus. This is the amount that they pay. And the amount of surplus is the value they get above and beyond the amount that they have to pay. So this area right here, this is consumer surplus if the price is $5. If the price is lower, what do you think happens to consumer surplus? Well, our consumers are going to receive more surplus. If the price is lower, more surplus. If the price is higher, less surplus, and so on. We can think about this consumer surplus is the value above and beyond what they have to pay that they get from consuming shoes. All right. So let's pick a level. I like $5. It's 5. We have 5 and 15. So let's pick a price. We're going to pick a price of $5 and use the graph to find the total value of consumer surplus. So at a price of $5, consumers are willing and able to purchase 15 pairs of shoes. And our consumer surplus is represented by this triangle underneath the demand curve up into the to the amount paid. Now, how do we find this value in a dollar amount? Well, this distance here, 13 minus 5 is equal to 8. So this is 8. This distance here, this is 15. The area of a triangle is equal to 1/2 the base of the triangle times the height of the triangle. Our base is 15. Our height is 8. So if we do this calculation correctly, that should be 120. And this area here is 60. So 15 times 8, I think, is 120, because 15 times 4 is 60. Yes. 15 times 2 is 30. Yep, that's right. So our consumer surplus in this example is $60. That's like saying our consumers get 60 additional dollars of value from consuming this good above and beyond what they have to pay. So let's bring our producers back in. And for simplicity, we're going to draw our supply curve in such a way that it crosses our demand curve at $5.15 shoes. Now, the supply curve represents the quantity that producers are willing and able to bring to market at every possible price, or the marginal cost of producing each additional unit. So I have it drawn here such that if the price of shoes were, here's $1, if the price of shoes were $1, producers would be willing and able to bring 3,000 shoes to market. This is in 1,000. Our units are in 1,000. If the price of shoes is $2, it looks like our firms are willing and able to bring 6,000 units of shoes to market, and so on. And so we would measure the total revenue, or the total value that producers would receive if they brought each shoe to market here. But this is our marginal cost curve, and the total costs that producers would face is represented by this area under this supply curve. So our firms collect this in total revenue. They pay this in total costs. And the difference between the two, or the area underneath the price and above the supply curve, is the additional surplus or profits our producers receive above and beyond what would be required to bring those units to market. So that's why our producer surplus is represented by the area under the price and above the supply curve. So in this picture here, at a price of $5, our producers are, not coincidentally, willing and able to bring 15,000 shoes to market. And we can find our producer surplus as the area of this triangle right here. The area of a triangle is 1/2 base times height. Our base in this case is 15 again, and our height is $5. 15 times 5, and this is in thousands. 15 times 5, I'll just punch this quickly, is 37.5 thousand. That's our producer surplus. Now, if we look at this messy picture here, we can find total surplus, consumer and producer surplus summed together. As economists, this is actually what we care about. Total surplus. Is total surplus as big as it could possibly be? In this market, there are no externalities. We know that if there are no externalities, then our demand curve is marginal private benefit is equal to a marginal social benefit. There are no externalities, so no positive externalities or negative externalities, so our supply curve is marginal social cost is equal to marginal private cost. And a market with no externalities that's perfectly competitive, that is in equilibrium with no intervention or price controls from the government, no taxes, total surplus, consumer surplus plus producer surplus is as large as it can possibly be. So in this case, economic surplus is maximized. And a good way to check this out is if you go to your interactive in the welfare section of the class and play around with the slider and see if you change the quantity to something other than the equilibrium quantity, you'll find that total surplus is smaller than the case when the market is in equilibrium. So now let's do something to make this market in such a way that total surplus is not maximized. So I wrote down monopoly right here. We're gonna do one thing. What do you think? Should it be monopoly or should I do an externality? Monopoly is actually pretty easy, right? Let's do a monopoly. Professor Jose has been taking a nap. All right, so let's make this a monopoly. If it's a monopoly, there's only one firm, right? So this is our single firm, and our single firm's supply curve is the marginal cost curve. Instead of it being a perfectly competitive firm where we would add up all the marginal cost curves of the firms producing. So we have a single firm. Now, here's our market demand curve. It's the same. There's a bunch of consumers. But now it's like we only have one producer of shoes. We only have one producer. We get one kind of shoes made by this manufacturer. This downward sloping demand curve generates a marginal revenue curve that's underneath the demand curve. And if you need to remember why, go ahead and watch the Monopoly video. But we don't have supply and demand like we normally have in a monopolized market because there's only one producer. So this is our graph. And look at this mess that we've made here. Well, what do we see from this mess? Is this the amount that's continues to be produced? Well, you should know the answer is no, because our firm is going to choose to produce the quantity where marginal revenue is equal to marginal cost. Oh, I've thankfully I've drawn it nicely, where we have that happening in a quantity of 9. So we know we're going to have fewer shoes produced. Now our firm can, if it's producing 9,000 shoes, can, even though it's a monopoly, it can't pick any price. The highest price it can pick to sell all of those 9,000 shoes is right here. Oh, fortunately, again, this happens at $8 a pair. So now this firm is going to choose to produce 9,000 shoes and charge $8 a pair. So we can find consumer surplus is the area under the demand curve to the price paid and the quantity consumed. So here's our consumer surplus. Now, you see it shrunk quite a bit because our consumer surplus used to be this whole triangle, and now it's this smaller triangle. But we still have some consumer surplus. We can find our new value, 13 minus 8 is 5. And then our base is 9. Our area of this triangle is 1/2 times 5 times 9. That's 1/2 of 45. 22.5. Thank you, Professor Jose, who's not taking a nap right now, who's helping me out. So there's our consumer surplus. But now our producer surplus looks a little bit funny. Our producers collect the area underneath the price all the way down to the supply curve and surplus. And it's this funny Nevada-shaped area right here. So what I usually do is I cut this, to help me out here, I'm going to cut this into 2 pieces. I'm going to find the area of this square and the area of this triangle right here. And so this triangle right here, this is 9. This is approximately 3. 1/2 of 3 times 9 is 1/2 of 27. That's 13.5. And then the area of this square right here, this is 5 times 9 is 45. So producer surplus is 58.5. So 45 plus 13.5. So what happened to our producer surplus? Our producer surplus used to be 37.5. It got bigger. Our consumer surplus got smaller. It used to be 60. Now it's 22.5. And if we sum these up, we'll find that it's less than it used to be. And we can see that. It's very obvious by looking at this graph, because this whole area used to be total surplus, and now it's only this whole area here. So what we've done is lopped the top off of this triangle. And this will be part of Professor Jose's talk too, is this area right here. This is our dead weight loss. Because this market is monopolized, this surplus is lost. And if we wanted to find the value of the dead weight loss, we would calculate the area of this triangle right here. So 8 minus 3, that's 5. 9 minus 15, that's 6. Area of a triangle is 1/2 base times height. Our base is 5. Our height is 6. 1/2, that's 15. So we have lost $15,000 of surplus because this market is monopolized. This is why economists don't like monopolies in general. Now we could do something very similar and add a tax. We could calculate what would happen to prices and quantities as a result of a tax, and we can compare the total surplus with the tax to the total surplus without a tax and find dead weight loss. We could study the case where We have externalities where marginal social cost is different from marginal private cost, or marginal social benefit is different from total social benefit, and compare total surplus in the ideal case and the case where we don't have externalities corrected. Or we could study what happens when we have markets that are do, say, tariffs and quotas. And that's what Professor Jose is going to do for you now, after I clean up this mess that I have made. You want me to leave my axes? Here you go.
No, I'd rather have my own.
And clean them up. Uh-oh, I used red for something.
While Kara's cleaning that up, I wanted to mention that the reason I appeared to be a little bit asleep is that I was actually marveling at the fact that she gave me two choices, whether to illustrate a monopoly or to illustrate an externality. And I was thinking that over the week, both of those things happened to be part of the headlines of the major newspapers. So for instance, there was a report recently about climate change and concern about that the principal source of global warming is emissions from coal firing plants. And so coal firing plants, of course, would be a good illustration of externalities, because they don't take into account the fact that they're emitting carbon dioxide into the air, and that has negative implications for future generations, right? But she also mentioned that she was going to give me the choice of monopoly, but monopoly is also in the news. Most of you, of course, have heard that Amazon has been trying has decided on where to locate, but there is now a growing literature in economics that's a little bit concerned about the role that these large global mega high-tech firms play, and the fact that maybe they don't quite have the competition that of course, perfectly competitive firms would have. And there's a concern that they're controlling prices and setting prices much like a monopolist. Okay, so I was actually marveling at those two choices, and I was thinking, which of the two would be more relevant for you to understand? So that was my hesitation, but she thinks too quickly and didn't let me decide on which one it would be. All right. So what I'm going to do is I'm going to continue to look at things that are in the news that are widely applicable that make relevant what you've been studying, show you that it applies to real life. And so I'm going to look at the issue of international trade, and tariffs, which of course has been in the news. We recently heard that General Motors is closing some plants, 5 plants to be sure, to be clear, and that one of the reasons they gave, in addition to consumer preferences, tastes are changing away from recently because of low fuel prices. Consumers are buying more pickups, large pickups, and also SUVs. And so there's been a shift away from smaller cars, and so they're having to shut plants. And but another reason they gave was that the costs of the cars have gone up because of the tariffs on steel and aluminum that were been applied by the Trump administration. All right, so we're going to look at tariffs. All right, so let's start with the small country case. And what I'm going to continue to do what Kara did in terms of illustrating how you go about calculating the impact of these tariffs on consumer surplus, producer surplus, and economic well-being of the nation as a whole. All right, so I'm going to put in a straight line here. So I'm assuming that this country is a small country in international trade. So this is going to be the world price. The world price of this particular product is $6. I'm going to make the calculation. The number is small, so it's easy to calculate, right? So that means that the nation, so let's say we are U.S. consumers, we can buy as much of this product as we want as long as we pay $6. And the rest of the world will supply an infinite amount of this to us at a price of $6. Okay, so let's add the domestic supply curve, and it's going to be upward sloping like this. And I'm going to write SD for domestic supply. That's the supply curve of domestic producers. And here's domestic demand added in. That's the demand curve by domestic consumers. And I'm going to be switching since I'm going to sometimes say by U.S. consumers instead of domestic consumers, and U.S. producers instead of domestic firms. So know that it's the same. All right, so here's the supply curve from the rest of the world. And so there we have it. Now, given that the price in the marketplace and in the domestic economy in the U.S. is going to be $6, domestic producers will, the quantity supplied will, for domestic producers, is going to be, let's say, $8, 8 units. So if the price is $6 per unit, domestic producers will put on the market 8 units. Domestic consumers, if faced with the price of $6, their quantity demanded is going to be, in this particular case, 26 units. Right? So at a price of $6, go to the demand curve and down, and you get the quantity demanded. Right? So what this means then is domestic consumers are consuming 26 units. 8 of these units are being supplied by domestic producers, and the remaining, the difference between 26 and 8, which is 18, are imports. So the United States is importing 18 units, domestic producers are producing 8 units, consumers as a whole are buying 26. Okay, so if this were the tariff on steel, let's suppose that the United States government has decided to implement a tariff on steel, and let's say it's a $1 tariff to make this simple. So that's going to mean that in order to gain access to a unit of foreign steel, not only will consumers have to pay $6, but they also have to pay the government $1 of taxes. So that means that the price of foreign steel will rise to $7. That's equivalent to just drawing a line like this, straight across, okay, where this is the world supply plus the tariff, now with the tariff. Okay, so this is now a price of $7. It includes the tariff amount. Right? So the domestic price has gone up by $1 because of the $1 tariff. And this is what happens in a perfectly competitive market. You can think of this as that the tariff is fully passed through into prices, okay, where it's a dollar tariff, so it's fully passed through to consumers in terms of the amount. The domestic price goes up by the same amount as the tariff. All right, so the higher tariff then is going to shield domestic producers, and so domestic producers are going to expand their production from 8 units. They're going to move up their supply curve to the new quantity supplied, and that's going to be they're going to expand production to 12. So domestic producers were initially producing 8. Now production is expanded by 4 units. So they've crowded out imports. They've replaced imports, and they've expanded by 4 units. The higher price of $7, though, means that domestic consumers are going to be purchasing a smaller amount, so their quantity demanded shrinks. And we move back up the demand curve to this amount, which I'm going to say is 20. So the quantity demanded has shrunk by 6 units. Right? So we've seen 2 effects of the tariff. The tariff has permitted U.S. or domestic producers to sell more units, so they're putting more units on the market by +4. At the same time, consumers then have cut back purchases of this product by 6 units. So, so price has gone up, domestic production has expanded, quantity demanded or demand has gone down. What are the implications of this, though, for the well-being of producers, consumers, and the nation as a whole? And that's what I'm going to turn to now. So in other words, I need to calculate the impact on consumer surplus, the impact on producer surplus, and then the overall impact on the nation. Okay, so let's start with the impact on consumer surplus. If you notice, if you paid attention to Kara's presentation, you would know that consumer surplus before the tariff increase was the area underneath the demand curve. So it would have been the area underneath the demand curve, but above the price that was being charged in the market, the price that consumers are paying in the market. So I'm going to make this a little bit darker so you can see that. So it would have been the area under the demand curve, but above the price that consumers are paying. So consumer surplus would have been represented by this triangle. Now, as a result of the tariff, and because consumers are paying a higher price, consumer surplus has shrunk to the area above the price that they're actually paying now, but below the demand curve, to this smaller triangle. So in effect, what consumers have lost is this strip, this rectangular strip plus this triangle. So consumers, as a result of the tariff, have lost this area. And I think I'll just go ahead and put letter A to represent this area. I'll put B here, C here, and D. Okay. So consumers have lost this amount of consumer surplus as represented by A plus B plus C plus D. All right, so what's a quick way of calculating this? Well, we can calculate the area of the triangle by the rectangle by the height times the width. And in this case, we know that it's gone up by $1, and the width is 20 units. Right? So I'm going to put impact on consumer surplus, change in consumer surplus is equal to, they've lost $1 times 20. So it's part of the loss. What else have they lost? Well, they've also lost area D. And to calculate that, since it's a triangle, it's 1/2 the height, which is $1, times the width, which is 6 units. So this formula here represents this entire area but in dollars. And it's the change. In case we can say this is 20 plus 3, so there's been a minus $23 lost of consumer surplus as a consequence of the tariff. Now, let's see what happens to producers. Producers, recall that producer surplus is the area under the price that they receive, but above the supply curve. So in this case, producer surplus before the tariff was this area that I'm not putting any label on, is this rectangle. So the dollar value of this area was the producer surplus before the tariff. Now, if you notice, now with the tariff, producers have expanded production up to this point right here. And so the area above the supply curve is now this original triangle plus this new area labeled A. And so now all we need to do is calculate the amount of dollars involved in area A. And so let's do that. The change in producer surplus is equal to, and notice we can again break this A into 2 parts, one which is a bit of a rectangle and the other one which is a triangle. So the first part of A is going to be, the rectangle is $1 height and 8 units across, which will represent this rectangle. So $1 times 8 plus this triangle here, and well, the height of the triangle is $1. The width of the triangle is 4 units. So 1/2 $1 times 4. So that gives us 8 plus 2 equals a minus 10. Plus 10, excuse me.
May I stop you for a second? I'm a little confused. Can you show me the two triangles that you're adding up? Maybe with
Okay, sure. Let me erase this a little bit to make room for calculations. Okay, so let's look at the area. I'm breaking up area A into. Put a little dot right there.
That's helpful. So
yeah, that's a rectangle and a triangle. Okay, so I've broken up area A into 2 parts.
And you can tell that
the height is going to be the tariff amount,
okay,
which is $1. The distance across, or the width of this triangle, is going to be 4 units.
And you found that by looking at the top part.
Yeah, from here to here it's 4 units. It's the same distance as this.
Okay,
Yeah.
Thank you.
I'm using geometry.
Yes, I couldn't tell quite.
Gotcha. Okay, so as you can see, at least you can possibly begin to understand why tariffs are implemented, and that is that they make producers more profitable. They're earning $10 more here, even though they're hurting consumers. Consumers are losing $23 of consumer surplus. Now, so I've taken into account the change in consumer surplus, the change in producer surplus, but what I haven't what I'd like to do is I want to factor in what is the impact on economic well-being, or the impact on the nation. And one thing I should do here is that I haven't taken into account the fact that there's another entity here that receives or loses money, and that is the government. So in this particular case, the government, by implementing a tariff of $1, is now able to generate tariff revenue, or revenue. So money is coming into the government treasury. What's the amount of government revenue? Well, let's look right here. It is represented by this rectangle C. And rectangle C can be calculated. Well, notice the distance from here to here represents the volume of imports. And what we know is that that distance is 8 units. If we look down here, with the quantity demanded is 20 with the tariff, the quantity supplied is 12 with the tariff, the difference between that is 8 units of imports. So the distance from here to here is the volume of imports. And on each one of these units, the government is imposing a tax of $1. So 8 times 1 government revenue, or a tariff increase, tariff revenue increase of $8. So the government revenue is equal to plus $8, which is calculated as what the $1 tariff applied on these 8 units of imports. So it's $1 times 8. So area C is $8. So now let's calculate the overall impact on the nation of the tariff, on economic well-being. Sure, consumers lose, but producers do gain, and so does the government. At the end of the day, though, what is the overall effect? Well, we have to add all these up, and what we get is a minus $5. So at the end of the day, the nation's living standard, or the nation, is poor by an amount of $5 as a result of implementing this tariff. In the limited time that's left, what I want to do is I want to break out, why are we poor? Why is the nation poor as a result of this $5 tariff? What comprises this $5? Well, the $5 is made up of areas B and area D, right? Because remember, consumers lose this entire area here, but area A is collected by producers and area C is collected by the government. So that means that the only things that are not sort of offset or collected by someone are areas B and D. B and D represent what we call deadweight losses. It's the loss to the nation. So what does B make up and what does D make up? Well, if we look at B, notice that before the tariff, U.S. consumers were gaining access to these 4 units by paying this price right here. This is the price that they were paying for each one of those, which is $6. So for each unit, the nation only had to pay $6 to purchase them. Now, however, the nation is encouraging domestic producers to produce more, but domestic producers are not as efficient in producing these units as the rest of. They're telling us this is what they're using up in terms of resources. By looking at the supply curve, we see what it's costing them per unit to give up to produce these additional units. So this area here then is a measure of the resource cost. They are inefficient, they stepped up production, they're wasting resources, and the dollar amount of that is B. What about over here? Oh, and B then can be calculated. It's the distance up is $1, the distance across is 4, so 1/2 $1 times 4 is $2. So this area, B, represents $2, and it's called production efficiency loss. The production efficiency loss. Right, let's look at D quickly. So before the tariffs, consumers were buying those units at this price given by here. So they were buying these 6 units at this price of 6. And consumers, even after the tariff, the nation as a whole still has the option of buying these units at those prices. But instead, the tariff, in a sense, restricts consumers from buying it. So consumers could have been receiving all of these benefits here that are represented by the area above the price but below the demand curve. This is consumer surplus that they could have achieved if they were permitted to buy the product at $6, but they're not. So they lose on the amount of consumer surplus represented by area D, and that's called the consumption efficiency loss of the tariff. And so B and D are 2 deadweight losses. Dr. Kara, is there time remaining? Do we have any more time?
We have 5 minutes. And we have 0 viewers, so I'm sure that many people will be watching this as a recording.
Oh, let me add one thing.
Okay.
Since there's 5 minutes. If you're reading the news, it turns out that the Trump administration is considering replacing the tariffs on steel and aluminum with quotas. Okay? And what does that mean? What would that mean in this? Could we analyze this in this graph? Well, it turns out that we actually can. So if the administration wants to limit the amount of imports to just simply 8 units, just like the tariff did, what's going to happen is that the graph would look the same. We would have the quota that would be shrinking the amount of imports to 8. Okay, so price would go up, consumer surplus would decline, producer surplus would rise, all by the same amounts. However, the impact on the nation would actually be potentially worse. There would be a bigger loss than -5 because Area C now would not represent government revenue. Right? In fact, Area C is called what are called quota rents. they may and most likely will go to the countries that export, that are able to get their products sold in the United States under the quota. So that would be additional revenue that would be going to foreign producers or foreign suppliers. It's as if the U.S. Treasury decided to write a check. When it goes to the quota, it's as if the U.S. Treasury is deciding to write a check to foreign suppliers. So that means then, in addition to the -5 we would lose, we would also be losing the government revenue, so that overall the United States would be poorer by -13.
So if we were in a negotiation and I'm the foreign country and you're the domestic country, what do I want? Tariff or quota?
Well, it depends.
Neither, right?
No, actually, it depends. If you're that's a great question, actually. It depends. And the reason it depends is that in the short term, if you're the foreign supplier, you want the quota. And in fact, when quotas were applied, called voluntary export restraints, applied to the Japanese auto industry, autos coming from Japan, it turns out that the Japanese producers were able to use the quota rents to upgrade the profits from that, to upgrade their cars into more luxury brands before they produced just a basic fuel efficient car, and they went upstream. For foreign producers is that if the U.S. market is growing, if there's an expansion in the demand, what happens is that they're not able to supply any more to this market, and the domestic price keeps going up, which is favorable to domestic producers, but not the foreign suppliers.
Okay. Good answer. Well, thanks for watching. I'm sorry you weren't able to join us, but it is maybe an awkward time. So post any questions you might have in the discussion forum. If you want any clarification about what we've talked about here, we will be monitoring throughout the week as the final exam is open. And we will see you there.
And good luck on the final.